So now that we've learned about the zero factor property, we can use that to help us solve our quadratic equations by factoring. The first step is that we're going to set one side of the equation equal to 0. So in essence, we're just pushing everything to one side, making the other side 0. Once everything's pushed to one side, we'll factor all that stuff completely using one of our factoring skills that we've learned. And then once it's factored, it'll say something times something is 0, and we can use that zero factor property we just learned to solve the equation. And as always, we can check our solutions if we would like. So we've got 4 steps to this process here. Get these out of the way. And we're going to look at our first example. Okay. So let's look at the quadratic equation x squared minus 3x minus 18 equals 0. So again, we had a 4-step process. The first step was that we wanted to push everything to one side of the equation. We wanted to set it equal to 0. And in this example, it's already done for us. Everything's on the left-hand side. It's already set equal to 0. So we can move on to step 2. And step 2 is where we want to factor that non-zero side completely. So we want to factor this trinomial. So remember all of our steps for factoring. The very first thing we look for is that it's in descending order. In this case, it already is. Second thing we look for is we want to look for a GCF, any number or letter other than 1 that these 3 terms might all share in common, but in this case we have nothing. So we now look at how many terms there are. Since there are 3 terms, we're going to go ahead and do that Xbox method. So I'm going to go ahead and do this right under here. We have a sum of -3 that we need. Remember, it's always the number in the middle. We have a product of -18, that last number. So we're looking for numbers that add to -3 and at the same time multiply to -18. What we end up with is we have a -6 and a +3, and you can double check. These add to -3 and they multiply to -18. But remember, we have to then ask, what are those numbers good for? And if there's nothing in front of the x squared, then those numbers can just be thrown right into our parentheses and get it factored already. So I'm going to throw that -6 in to the parentheses with an x, and I'll throw this +3 into another set with another x, and this is still an equation set equal to 0. Let's make sure that we're not changing equations into expressions. If there was an equal sign at the beginning, there's got to be equal signs all the way through the problem. I don't want to change the nature of the problem. So basically this problem is going to consistently have an equal sign in every step. But at this point, we had it set to 0. We've factored the non-zero side. It says something times something. And we know that the factoring's done because each of these factors are linear. There's no visible exponents. Remember, when they're linear, we leave them. So if something times something is 0, one of those has to be 0. That's that zero factor property. So either the x minus 6 must equal 0, or the x plus 3 must equal 0. Now, if x minus 6 is 0, I can move that 6 to the right by adding it. I get x equals 6. For the other equation, I can move the 3 to the right by subtracting, and I get x equals -3. So I've solved for x, and I've found 2 solutions. And a neat thing about polynomials in equations is that whatever the highest exponent is, we call that the degree of the equation, and that degree tells us how many solutions or how many answers we should get. So this degree 2 equation, this quadratic equation, tells us there should be 2 solutions, and it looks like we found both of them. Now, if you wanted to, you could check your answer. You could plug in a 6 everywhere you saw an x and see if it's true. So let's try that just in our head. We've got 6 squared, that should be 36. And then we've got -3 times the 6, so that's -18. So 36 minus 18 is 18. Minus another 18 is in fact 0, so the 6 checks out. We can try the same thing for -3. if I took negative 3 and squared the whole thing, that means negative 3 times negative 3, I would get a positive 9. And then minus 3 times negative 3, that would be another positive 9. So I've got 9 plus 9, which is 18, minus another 18 gives me a 0. So the negative 3 checks as well. So I have found my two solutions, and I know there are not going to be any more solutions to the equation because, again, it started off as a degree 2. The highest exponent was 2. I know there should only be those two answers. Okay, we'll try another one. All right, we'll try negative 5x squared plus 20x plus 60 equals 0. So again, we've got 4 steps. First step is I want to push everything to one side, make it set to 0, and it looks like that's already been done for us. Second step is whatever's the non-zero side, we want to factor that completely. So again, our factoring steps. Number 1, I want it in descending order. I've got descending order already done for me. Step 2, I want to factor out any GCFs that we might have. And so if I look at these 3 terms, I can see that they all share the number 5 in common. 5 goes into all of these. More than that, I'm going to note that the very first term has a negative. And so remember our rule that if the first leading term has a negative, we're going to factor out a negative with that GCF. So let's pull out a negative and then 5 for the GCF and see what's left here in parentheses. So negative 5 times what is negative 5x squared? That should be an x squared. Negative 5 times what is 20x? That should be a minus 4x. And negative 5 times what is positive 60? That should be a negative 12. It's still an equation set to 0. So again, I don't want to change the nature of the problem. If it started off as an equation, it needs to have an equal sign in every single step. So now this is factored. It says something times something, but it's not factored completely. I know I can leave the negative 5 because that's just the GCF and I leave those alone. But let's look at what's going on here with this trinomial. Like the last example, we know trinomials can be handled with that Xbox method. So I'm going to do the Xbox method down here. The sum is again that number in the middle. So we've got negative 4 for our sum. Product will be our last number, which is negative 12. So we're looking for numbers that add to negative 4 and multiply to negative 12 at the same time. So it looks like the numbers that'll do that is a negative 6 and a positive 2. Double check, when you add them, you should get negative 4. When you multiply them, you should get negative 12. And again, with this technique, we have to ask, what are those numbers good for? In this case, since there's nothing in front of that x squared immediately, I'm not talking about the negative 5. We've ignored him. We've pulled him off. But there's nothing in front of the x squared here. So those numbers, again, get thrown into the parentheses immediately. So in parentheses, I'll throw that negative 6. In another set of parentheses, I'll throw that positive 2. Don't forget there's still that negative 5 GCF out here. There's still an equals 0. It's still an equation. And again, it's factored. It says something times something times something is 0. Let's make sure that we're done factoring. We know GCFs we can leave alone. These two factors are linear because I don't see any visible exponents, and if they're linear, we leave them. So if it's factored completely, we move on to step 3. If something times something times something is 0, then one of those factors must be 0. So either negative 5 equals 0, or x minus 6 equals 0, or x plus 2 equals 0. One of those has to be 0 for this equation to ring true. Well, like we've seen before, we can't let a constant equals 0 because negative 5 just will not equal 0. So we're going to cross that one out. That leads to a dead end, so we can ignore it. These other two pieces, however, will give us solutions. For this first one, to isolate the x, we're going to move 6 to the right, and we get x equals positive 6. For this third one, we've got the 2 moving to the other side. It becomes negative, so x equals negative 2. So the first factor led to a dead end, but the other two factors gave us solutions. And again, if you went back to the beginning, looking at the degree of the equation, it wasn't, again, a degree 2 equation, a quadratic equation. That degree 2 tells me there should be 2 solutions, and we have found the 2 solutions. Again, you could plug those in back to the original equation. You can say if x is 6, does this ring true? And it should. Same thing with the negative 2. You can always plug in your solutions to double check the answers. We'll look at another one. Okay, let's look at 2x cubed minus 18x equals 0. Okay, so again, step 1 is we want to push everything to one side, set it to 0. And again, we have an example where that's been done for us. So step 2, we factor that non-zero side. Again, for factoring, we want it to say something times something. So step 1, we want descending order, already got it. Step 2, we look for a GCF. These two terms share a couple things in common. First, they share a 2 in common. 2 goes into 2 and 18. But also they share an x in common. So we're going to pull 2x out as the GCF. And in parentheses, we'll write what's left. So 2x times what is 2x cubed? We should get x squared. And 2x times what is negative 18x? And we should get minus 9. It's still an equation set equal to 0. So again, keep it an equation all the way through. We have factored, it says something times something, but have we factored all the way? The 2x was a GCF, we can leave that alone. But this x squared minus 9, we can go further with. This is a difference of squares. We know those can factor. For a difference of squares, we can set up our parentheses. We know it's going to be something times something. For a difference of squares, we'll have one with a plus sign, one with a minus. And since it's that difference of squares, we're going to take square roots straight down. So the square root of x squared is an x. The square root of 9 is a 3. And then we copy those terms over here. Don't forget the 2x, it's still out front. And don't forget that equals 0, it's still an equation. Something times something times something. It is factored. Is it factored all the way? 2x is a GCF, we leave it. These two factors are linear because we don't have any visible exponents, and linear factors we can leave. So this is completely factored, and we know for step 3, if something times something times something is 0, one of them has to be 0. So either 2x equals 0, or x plus 3 equals 0, or x minus 3 equals 0. For this first equation, it's not like the last one where we had negative 5 equals 0 and we said that can't happen. This says 2x equals 0. We can solve this one for x. All we have to do is divide both sides by 2. That would give us x equals 0 divided by 2, still 0. So because that factor had an x in it, we could solve for it. If it didn't have an x and it was just a number set to 0, nothing we can do. It'd be a dead end. Okay, the next one, we'd send the 3 to the right. It becomes negative 3. And this last one, we send the 3 to the right. It becomes a positive 3. So it looks like here we've got 3 solutions. We have x equals 0, x equals negative 3, and x equals positive 3. And if we look back at the original equation, it was a cubic equation, meaning it was degree 3. The highest exponent was 3. That tells us there should have been 3 solutions, and we happened to find all 3 here. Okay, we'll look at another one. What you'll notice with all of these solving equation examples is that really the majority of the work and the majority of the math comes in the factoring step. And that's what we've spent this entire chapter practicing our skills on, is the factoring. That's where all the work comes in. And really the only way I can make these problems harder for you is to make the factoring part harder. So let's try some more problems here. We've got 3x cubed minus 9x squared minus 12x equals 0. And even before starting this one, I can look at the degree and I can tell ahead of time we're going to get 3 different solutions here because this was a cubic or degree 3 equation. So let's see if we can get those 3 different solutions. Step 1, again, we want to push everything to one side, set it to 0. It's been done for us. Second step, we want to factor everything on that non-zero side. So for factoring, we look for descending order, which we've got. We look for a GCF next, and it looks like 3 is the number that goes into all 3 of these terms. We also have an x in all of these terms, so we're going to factor out a 3x. And in parentheses, we'll write what's left. So 3x times what is 3x cubed? That should be x squared. 3x times what is negative 9x squared? That should be negative 3x. And 3x times what is negative 12x? That should be minus 4. And again, it's still an equation set to 0. So we factored, it says something times something, but have we factored all the way? We know 3x is done because it's a GCF. But this piece, this trinomial, might be able to be factored further. The way we factor trinomials, again, is that x box. So the sum, again, is the middle number. Here it's negative 3. The product is our last number here, which is negative 4. So you're looking for numbers that add to negative 3, multiply to negative 4 at the same time. So in this case, that'll be a negative 4 and a 1. And you can double check they add to negative 3. They multiply to negative 4. And what those numbers are good for, since there's not technically anything right in front of that x squared, we take those numbers, we throw them into parentheses. So in parentheses, I'll have the negative 4 with the x, so x minus 4. In parentheses, I'll throw that positive 1 in with the x, so I've got x plus 1. Don't forget the 3x, which is still out front. Don't forget the equals 0. We still have an equation. So now something times something is 0. One of them has to be 0. We know this is done, I guess I should say, we know this is completely factored. GCF we always leave. Linear factors we leave alone. So we can do that third step, something times something is 0. One of them's got to be 0. So either 3x equals 0 or x minus 4 equals 0 or x plus 1 equals 0. Again, since there's an x in that equation, I can solve it. I just have to divide by 3 to get the x by itself. And 0 divided by 3 is still just a 0. Here, I'll move the 4 to the right by adding it. I'll get a positive 4. Here, I'll move the 1 by subtracting it. I'll get a negative 1. So again, I have 3 solutions to this equation. We had already predicted that at the beginning. We knew that because it was degree 3, because it was cubic, we would have 3 different solutions. And again, you can always check that by plugging each solution in and seeing if the equation's true. All right, now so far we've seen examples that are already set equal to 0. So now we're going to see what happens if our initial equation is not already set equal to 0. How do we handle that? So let's look at 25x squared minus 29x equals negative 4. All right, so step one is to set it to 0. We have not had to do this before. It's been done for us up till now, but we can see that we don't have a 0 on either side. So what I'm going to do is I'm going to push everything to the left. Essentially, in this case, that's just taking this -4, scooting it over. So we've got our 25x squared. We've still got our minus 29x. But now if this -4 scoots to the left, it becomes positive 4. And that leaves us with a 0 on the right, which is exactly what we want. So step 1 now is done. We've set it equal to 0. Now step 2, we have to factor that left side. So for factoring, we want descending order, and I've already got it in descending order. We look for a GCF, and these don't have any numbers in common other than the 1, so we don't have a GCF to pull. And so we look at how many terms, and for 3 terms, again, we're doing that X box. So I've got, in fact, I'm going to do this off to the right because I feel like I'm going to run out of room here. So for this X box, the sum we're after, again, is always that middle number, so -29. The product, however, we have to be careful here. This is different than the last few we've seen. With that coefficient in front of the x squared, remember that means we're doing that AC method. So you have to multiply to get your product. You have to multiply first times last. So that's 25 times 4. If you've got 4 quarters, you've got a buck. So 25 times 4 gives us 100. So we're looking for numbers that add to -29 but multiply to positive 100 at the same time. So that should be -25 and -4, and you can double check. They should add to -29. They should multiply to positive 100. Now what do we do with those two numbers? In the last several examples, we took those two numbers, we threw them right into parentheses, we said our factoring was done. But it's different here. Again, because of that number in front of the x squared, it's not that quick and it's not that easy. These numbers tell us how to split that middle term. This is that AC method we've seen. So we've got the 25x squared, and now this -29x splits into 2 pieces. It splits into -25x and then -4x. And then we still have the +4 = 0. So what we've done in splitting that -29x, we've created now 4 terms instead of the original 3 that we had. And anytime you've got 4 terms, what you want to do is you want to group. So if I look at the first group, my GCF there looks like a 25x. And if I look at the second group, my GCF looks like a 4. And what we do with GCFs is we always pull them out. So for our first group, let's pull out that 25x. What'll be left is x minus 1. And then be really careful. Don't forget, we always drop the middle sign. So I'm going to drop that minus. Pull out the GCF of 4, but just be really careful because what we're technically pulling is a -4. Anytime you pull a negative, you got to be careful of the signs. -4 times what is -4x? That should just be an x. -4 times what is +4? That should be a -1. Couple things to watch for. Make sure that your parentheses match. Make sure it's still an equation set to 0. Now this isn't factored yet, because to be factored it means it has to say something times something. This says something minus something. So we have to keep going. What we notice at this point is these parentheses match. That tells me it's a GCF. It's a common factor that I can pull. So let's pull x minus 1. And if I pull that x minus 1 from the first term, I've got a 25x left. If I pull x minus 1 from that second term, I've got a -4 left. It's still an equation. Again, every single step should have that equal sign. Something times something is 0. One of those has to be 0. I know I'm done factoring though because it's linear factors and I leave linear factors alone. So something times something is 0. Either x minus 1 is going to be 0 or 25x minus 4 is going to be 0. One of those guys has got to be 0. For the first linear equation, I'll move the 1 to the other side. I get x equals 1 for a solution. I'm running out of room here, but if I move the 4 over and then divide by the 25 to get x by itself, I'll go ahead and do both of those steps at once. So moving the 4 gives me a positive 4 on the right, and then dividing by 25, I should get 4/25. So there are my two solutions, and I was expecting two solutions because this was a degree 2 quadratic equation at the beginning. So this one took quite a bit of work. Where was the work though? It was in the factoring. Here was us setting it to 0, and then all of this work was getting the factoring part done. So again, the bulk of the work in these problems is the factoring part. That's where it gets tricky. That's where it can get difficult. That's the only place where I can make these problems harder, is in trying to get the factoring to take a long time. All right, let's do another one. Again, this one was different from the first 4 because we had to set it to 0 first. So let's do another one just like that, where we have to work to get it to equal 0. Okay, so this time we've got 4x squared minus 20x equals negative 5x squared minus 6x minus 5. All right, so first step, I have to set it equal to 0, meaning I'm pushing everything to one side. Now, it really doesn't matter which side you push to. You can push everything to the right, you can push everything to the left, it's totally up to you. Keep in mind, though, that you don't want to have to play with negatives if you don't need to. So, for example, I don't necessarily want to push everything to the right, because if I did, subtracting 4x squared would make a negative 9x squared over here. I don't really want to deal with a negative. I like my leading term being positive if I can make that happen. So I'm going to still push everything to the left like I've been doing. So I'm going to add 5x squared to both sides. That will give me 9x squared. I'm going to add 6x to both sides. That gives me minus 14x. I'm going to add the 5 to both sides. And this is now set to 0. So once it's set to 0, step 2 is we got to factor. First step is to look for descending order. We've already got it. Second is we want to look for GCFs. I have none. Third is to look at how many terms, and I've got 3 terms. That tells me X box. So again, I'm going to run out of room if I don't go off to the side to do this. The sum I'm looking for is a negative 14. The product I'm looking for is first times last. So again, watch out for that leading coefficient. First times last, 9 times 5 should be a 45 here. So the numbers that add to negative 14 and multiply to 45, that should be a negative 9 and a negative 5. Again, double check that they add to negative 14, that they multiply to positive 45. And then we have to ask, what are those numbers good for? Are they good for throwing in parentheses and being done with the factoring, or do they split the middle term? It has to do with whether or not there's a number out in front here. Since there's a 9, since there's a symbol there, it's not too easy. It's not where we just throw it in parentheses. We're going to have to split that middle term again. So this negative 14x is going to split into 2 pieces from these numbers here. So we've got the 9x squared. And now that negative 14x splits, we'll have a minus 9x and a minus 5x. We still have plus 5 equals 0. In splitting that negative 14x into 2 pieces, we now have created 4 terms. Anytime you have 4 terms, you want to factor by grouping. So we're going to group the first 2 together, and we see that their GCF is going to be 9x. And then we'll group the second 2 together. We see that their GCF is 5. And what do we do with GCFs? We pull them out. So I'm going to pull out 9x. In parentheses, I'll write what's left. Looks like an x minus 1. Again, don't forget to drop the middle sign. When we do our factoring by grouping, we always drop that middle sign and we pull out that GCF of 5. But again, watch for the sign. If ever we pull out a negative, signs will change. So negative 5 times what is negative 5x? It should be just an x. And negative 5 times what is positive 5? That should be a minus 1. Again, a couple things to watch for. Parentheses ought to match. That's a good thing that they do here. We also need to make sure that we keep this an equation set to 0. Every line in our problem should have an equal sign. All right, is this factored yet? Well, it doesn't say something times something. It says something minus something. So we haven't finished factoring. But what we can notice is that the parentheses do match. That tells us it's a GCF that we can pull out. So x minus 1 pulls from the first term, leaving a 9x. And x minus 1 pulls from the second term, leaving a minus 5. And it's still set equal to 0. It's factored now because it says something times something, and we know it's factored completely because these factors are each linear. So when we don't see those visible exponents, when it's linear, we leave it. But now we can go to step 3. Something times something is 0. One of those has to be 0. So either x minus 1 is 0, or 9x minus 5 is 0. So from this first one, if I move the 1 over, I get x equals positive 1. And then for this one, again, I'm running out of room, so I'm going to go ahead and add the 5, and at the same time divide by that 9. So adding 5 gives me a 5. Dividing by 9 turns it into 5/9. So I end up with 2 solutions. And again, if I look back at the original equation, I see it was a degree 2 quadratic. I was expecting 2 solutions, just like this. So again, this one was very much like the last one. We had a lot of work to do here because we were doing that AC method for factoring. It had a lot of steps to it. Again, the only way these can get long and complicated is if the factoring is long and complicated. All right, we've got a couple more examples to look at, and these ones are going to present some cases where we have a little bit something tricky going on. We're going to look at cases where we've already got something factored to begin with, and we have to make an assessment of whether the factoring that's been done has been in our favor or not. So let's look at this example first. I'm going to have the quantity x plus 3 times the quantity 3x squared minus 20x minus 7, that product equaling 0. So if you have parentheses already in place, if you have something already factored, i.e. it says something times something, sometimes that's in our favor, sometimes it's not. So we have to decide whether it is. We're going to say it's in our favor if it helps us lead ourselves to that third step of our equation solving. So if it helps us get to that ultimate goal of saying something times something is 0, then we're going to go ahead and keep the parentheses because they're helpful. But if it says something times something is 2, that's not helpful. There is no 2 product property, but there is a 0 product or 0 factor rule. So if it's something times something is 0, leave those parentheses. They're there to help you. If it's something times something is some other number other than 0, don't leave them. In this case, it's something times something is 0. So I like these parentheses being here. This is something where it's factored, it's set equal to 0. I can use that. I can work with that. But I do want to make sure that my factoring is done completely. So my equation's set to 0. Great. It is factored, but not completely. So we got to keep working to get that done completely. The first factor is fine because it's linear. I see no visible exponents, so that linear factor I'm going to leave. But this other factor is a trinomial. Again, we're going to deal with that with the Xbox method. And just to make sure I don't run out of room, I'm going to go off to the side to do this. I've got a sum of negative 20. That's, again, that number in the middle. I've got a product of negative 21. That's the first times the last, so I have to do that because of the leading coefficient there. So 3 times negative 7 is a negative 21. So I'm looking for numbers that add to negative 20 and multiply to negative 21 at the same time. That looks like it's going to be a negative 21 and a positive 1. Again, you can check negative 21 plus 1 is negative 20. Negative 21 times 1 is negative 21. But what are those numbers good for? Those numbers can't just be thrown into parentheses where we say it's factored and it's done. Those numbers are going to split that middle term only because of that leading coefficient 3. So let's see how this works. We've got this x plus 3 out front. We said that that was a linear factor and we were going to leave it. Let's make sure we actually leave it there. Let's make sure it's still written out front. But this trinomial here, this is what we're going to work on now. I've got the 3x squared, but this negative 20x is going to split into two pieces. We've got negative 21x, we've got plus 1x, and then we've got our minus 7. It's still an equation set to 0. Again, this linear factor that's out front, we're just going to keep copy pasting, copy pasting, copy pasting. It's linear and we're leaving it. It's this big piece here that we're working on. And in splitting that middle term, we've now created 4 terms here, which again, we will factor by grouping. So let's look at the first group. It looks like their GCF should be 3x. Let's look at the second group. I don't see any number or letter in common, so the only thing they share in common is a 1. Remember that 1 is boring because everything has 1 in common, but I'm still going to write it down. What I do with GCFs is I pull them out. I'm going to temporarily ignore this linear factor that I'm leaving for now. I'm going to temporarily ignore it, and right now I just want to focus on factoring out these GCFs from their groups. So 3x is going to pull out, and what's left is x minus 7. Again, don't forget to drop, when you're doing grouping, to drop that sign in the middle, so I'm dropping the plus sign. I'm pulling out a 1, which isn't going to change anything, but I'm going to go ahead and write that to help me with my last step of factoring. So I'm pulling out a 1, and it doesn't change anything else here. It's just x minus 7 still. Few things to note at this point. Parentheses ought to match, so that's a good thing that they do. Other thing to notice is this should be an equation set to 0 still. And then the last piece, which is really important, is I can't completely forget this x plus 3 that was out front. It's still out front, but we have to be really careful. If I leave it just like this, the only thing he's getting multiplied to is this first term. He needs to be multiplied by everything, because that x plus 3 was multiplied by everything in the first step. It was multiplied to everything in the second step, and so I need to put brackets around all this stuff here to show that this factor is getting multiplied to everything here. So now at this point, I'm going to copy down that x plus 3. I just copy pasted him in every single step here. And now here with these matching parentheses, I call it a GCF, and I pull out that x minus 7 that they shared in common. And when I pull that x minus 7 from that first term, the 3x is left. And when I pull that x minus 7 from the second term, it's a plus 1 that's left. So now it's something times something times something. That is factored, but this time it's factored completely because each of these factors is linear. They each don't have visible exponents. Linear factors are left alone. Don't forget, it's still an equation set equal to 0. And if something times something times something is 0, one of those has to be 0. So either x plus 3 equals 0, or x minus 7 equals 0, or 3x plus 1 equals 0. So in this first equation, I'm going to move the 3 to the right. That gives me a solution of x equals negative 3. For the second piece, I move the 7 over to the right. That gives me an x equals positive 7. And for the last one, I've got a couple steps. I'm going to move the 1. That'll get me a negative 1 on the right, but then I'll divide by that 3. So x equals, again, when the 1 moves, it becomes negative. And 1 divided by that 3, that should give me a negative 1/3. So I've got 1, 2, 3 solutions. Now, I've said before that the degree of the original equation should tell you how many solutions you have. This one was kind of hard to see that because the highest exponent I see is the 2. But this wasn't completely distributed to begin with. If I actually distributed all this stuff, I would end up with a 3x cubed as my first term, and that cube tells me there should be 3 solutions. Another way of looking at it is this piece is linear, where the exponent is 1. This piece is quadratic, where the exponent is 2, and altogether that is a highest exponent of 3. There's my 3 solutions. So 1 solution came from this piece, 2 solutions came from that piece where it was degree 2. Again, the big bulk of the work here is in the factoring. That's why we've spent weeks doing the factoring practice. So if you can get that factoring down, you can solve these equations. So we're going to look at one more example. Again, I'm going to start off where something's factored, but this time the factoring isn't going to be there to help us. Here, something times something is 0. That was helpful. Now we're going to have an example where the factoring is totally useless, and we're just going to have to undo it. All right, so here's our last example. We've got x times x minus 4 equals 5. So I want you to notice it does say something times something. So there is a factorization happening, but it doesn't say something times something is 0. So it doesn't work with that 0 factor property. It says something times something is 5. I don't have a special rule that revolves around 5s. I have a rule around 0. So I have no guarantees about what these factors are at this point. My only option then is to just get rid of the parentheses because they're not helping us. So I'm going to distribute to eliminate these parentheses. So x times x is x squared. X times minus 4 is minus 4x. So I'm getting rid of the parentheses. I'm undoing the factoring because the factoring wasn't helping me. It didn't say something times something is 0. So factoring has been undone. Now I can kind of start over the process, push everything to one side. So let's move that 5 over. We get x squared minus 4x minus 5 equals 0. And now that it's set to 0, now I'm going to go and factor that left-hand side so that it'll say something times something is 0. So again, with the factoring, we want descending order, which it is already in. We want to look for GCFs, which there are none here. So now we are going to look at how many terms, and again, we've got the trinomial, so we're doing that X box. I'll go off to the side here just to make sure I've got room. The sum that we're after is that middle number, -4. The product we're after is that last number, -5. So we're looking for numbers that add to -4 and multiply to -5. And that should be a -5 and a 1. And you can double check. -5 plus 1 is -4. -5 times 1 is -5. What are the numbers good for? Well, the last several examples we've done, we've had to use them to break the middle term, but we don't always have to do that. There is nothing in front of this x squared, so those numbers, I can throw them into parentheses and just be done. So I've got in parentheses this -5 going in with the x, and in another set of parentheses, I've got that +1 going in with my x. Don't forget though, this is an equation in every step. We had said last step this was set to 0. So I've got something times something, that means it's factored. It's factored completely because I don't see visible exponents. So these are linear factors, and linear factors are left alone. And if something times something is 0, one of those factors has got to be 0. So either x minus 5 is 0, or x plus 1 is 0. So solving these equations, we move the 5 over, we've got x equals 5. Moving the 1 over, we've got x equals -1, nice and clean on this one. We've got 2 solutions. And again, it wasn't necessarily obvious at the very beginning that this was degree 2 for 2 solutions because I didn't see any exponents at all, but technically once I distributed, I saw the square. That degree 2, that quadratic, tells me there should be those 2 solutions there. So for all of these examples, whenever we're solving these equations by factoring, we're always setting the equation to 0, we're factoring that non-zero side, we're using the zero factor property to say if something times something is 0, one of them's got to be 0. And once we've got those answers, you always have the option to check by plugging those solutions into your equation and see if they pan out for you.